take the derivative of the general form of a to the x, it's a to the x times the natural log of a. So in this case, times the derivative of whatever the exponent is. The derivative of the exponent is 2, so I'm going to go ahead and write that in front. Then you're going to have 7 to the 2x times the natural log of 7. Do not multiply these together because this is not raised to the same exponent. So this is your final answer. The derivative of natural log is 1 over the argument, so 3x squared minus 7, and times the derivative of the argument, which in this case is 6x. So it's 6x over 3x squared minus 7. Alright, so in this case we're going to have 1 over the 2x minus 7 times the derivative of this, which is going to end up being in the numerator. But since we have a different base other than the e, we need to write natural log of 3 in the denominator as well. Alright, we're multiplying these together, so that means the product rule is involved. So the derivative of the first is 7x to the 6th times the second, plus the derivative of the second, 7 to the x times natural log of 7, times the first. Alright, you can use the chain rule here, or you can just simply multiply these exponents, so it's 2 to the 3x. So when you take the derivative, it's the derivative of the exponent, which is 3, times 2 to the 3x times the natural log of the base, 2. Derivative of 4e to the 10x, you need to have this, the derivative of 10, x is 10, so you're going to have 10 times 4e to the 10x. The derivative of 5 is 0, so this is simply 40e to the 10x. Alright, product rule involved because you have two functions of x. So the derivative of the first is 10x times the second, plus the derivative of the second would be 3e to the 3x times the first. So this means our derivative is 10x e to the 3x plus 15x squared e to the 3x. Do we have to use quotient rule here? You can, but you don't have to. You can realize this is a 1/10 in front of 3 to the 4x plus 1. So it's just a scalar multiple. So the derivative is going to be 1/10 times the derivative of this, which is going to be at 4. And then 3 to the 4x plus 1 times your natural log of 3. So you can simplify this 4 into 10. This 4 divided by 2 is 2, and 10 divided by 2 is 5. So we have 2/5 times 3 to the 4x plus 1 times the natural log of 3. Alright, so the derivative of the natural log of, or log of anything, is 1 over that thing times the derivative of that thing. So basically the derivative of the argument ends up being in the numerator, and the argument itself is in the denominator. And then we have a 7, so we don't forget to multiply by a 7 from our original equation, just a scalar multiple. But since we have a base of 4, we need to multiply the denominator by the natural log of 4. So this is 14x over x squared plus 5 and the natural log of 4. Looking at this, we have natural log of e cancel each other out. So this is simply 3x squared minus 7x, and the derivative of that, really easy, 6x minus 7. Alright, the outer function is e in this case. It's a peanut M&M with the e, and then a sign, and then your 3x. So the derivative of e to anything is e to that thing, times the derivative of that thing. So the derivative of sine of something is cosine of that same thing times the derivative of that thing, which is 3. And write it in front. Product rule. we have the derivative of the first, which would be negative e to the negative x times the second, plus the derivative of the second, negative sine x, times the first. So we have negative e to the negative x cosine x minus e to the negative x sine x. Alright, rewrite this. Trig, remember to rewrite it if you have it raised to a power. So tan of e to the 3x in parentheses squared. This is another peanut M&M. We have the outside squared, and then we have the inner tan, and then we have the e to the 3x. So the derivative of the outside is going to be 2, lower the exponent by 1, tan of e to the 3x. Notice I did not change the inside. On the same line, guys, please, 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 on the same line to chain. Don't go down to different line. The derivative of tangent is secant squared. Again, do not change the inside. Still on the same line, the derivative of e to the 3x is 3 e to the 3x. So looking to see what we can multiply this 3 and 2. So we have 6 e to the 3x, tangent of e to the 3x, secant squared of e to the 3x. Alright, have to use the product rule here. So the derivative of the first times the second plus the derivative of the second times the first. And then we have minus the derivative of x, which is 1. This is natural log of x. These cancel, so you have plus 1 minus 1. So it's just the natural log of x. Alright, so we're going to have 1 over secant x plus tangent x times the derivative of this. So that derivative ends up being in the numerator. The derivative of secant is secant tangent. The derivative of tangent is secant squared. Alright. So, looking at this guy, I'm going to go ahead and rewrite it and bring this to like this. So we have 2 natural log of x over x squared. So the 2 is just going to be a scalar multiple. We have the quotient rule. So it's going to be 2 in front times whatever we get. The derivative of the first, which is 1 over x, the top times the bottom, minus the derivative of the bottom, times the top, all over the bottom squared. So x squared squared. This x cancels with one of those. So we have 2 times x minus 2x ln x over x to the 4th. You can keep it like that, or you can write 2x minus 4x natural log x over x to the 4th. Either of these answers. Okay, x to the e. Now think about this. X to any power, you bring down the power, lower the exponent by 1. X to the n, the derivative will be n x to the n minus 1. That's the power rule. So this is x to the e, so it'll be ex to the e minus 1, plus the derivative of e to the x, z to the x. F prime of x, okay, derivative of secant of 3x would be secant of 3x, tangent of 3x, times 3. And then it's just 4 secant of 3x times the natural log of 4. This stuff right here is the derivative of the exponent. That's what we always do. Alright, rewrite this. Do not use the quotient rule if at all possible. So remember the log of a over b is the same as the log of a minus the log of b. So this is the same as this. The derivative of log of 6x plus 4, 6x plus 4 goes in the bottom. The derivative of this goes in the top, and then you have to divide by the natural log of 5. Minus 2x minus 3 goes in the bottom. The derivative of this, which is 2, goes in the top, and then you need to divide by the natural log of 5. You can just keep it like this. You don't need to find a common denominator. Alright, 3 and then log base 3. These undo each other, just like e and natural log undo each other. So you have secant of 2x minus 1, and the derivative of that would just be secant of 2x minus 1, tangent of 2x minus 1, times the derivative of this inside, which is 2. Also, don't forget to study derivative of the inverse. Where f, or g prime of x, is 1 over f prime of g of x. So these numbers in the parentheses are different. For instance, if you knew that f was x squared, and I know that g and f are inverses, and I want you to find g inverse, or g prime of 25. Do not find g. That's not what I'm asking. I'm asking for g prime. So what you need to do is you need to figure out f of something equals 25. Well, f of 5 equals 25. Because 5 squared is 25. So that means g of 25 is 5. These are paired together. So the derivative at 25 of g is the reciprocal of the derivative at f at 5. So you need to find f prime. Looking here, f prime would be 2x. F prime of 5 is therefore 10. So this guy's the reciprocal, so it's 1/10. So you need to know how to do this as well. Happy studying!